Hello. In this example, we're going to find the vertex and axis of symmetry of f of x equals x squared minus 6x plus 7 and put it in standard form. Then we're going to find the domain and range and any x and y intercepts, and then we're going to graph it. Now, to find the vertex, we need to remember the vertex formula, and that is h equals negative b over 2a. Now, if you remember, a is the number in front of x squared, b is negative 6, and c is 7 here. So negative b does not mean that it's always negative. It just means the opposite of b. So it's the opposite of negative 6 over 2 times a, which is 1. And then you'll simplify it. And simplifying is opposite of negative 6 is positive 6. 2 times 1 is 2, so 6 divided by 2 is 3. That means that the x-coordinate of the vertex is 3. Now, to find the k value, or in other words the y-coordinate, you just have to find f of, in this case, 3. So this is going to give us 3 squared minus 6 times 3 plus 7. Now, 3 squared is just 9. Negative 6 times 3 is negative 18. And then plus 7. So 9 plus 7 is 16. Negative 18 plus 16 is negative 2. Fantastic. So the vertex here is going to be the coordinate 3, negative 2. Now, the standard form, because of this, is going to be f of x is equal to a, which is in this case 1, so I don't need to write it, and then parentheses, x minus the x-coordinate, which is 3, squared, and then plus the y-coordinate, which is negative 2. So I'm just going to write minus 2. Fantastic. So here's the vertex. Here is the standard form. Now, notice that it's the same thing as x squared minus 6x plus 7. If you were to FOIL this x minus 3 squared out and then subtract 2, you will get x squared minus 6x plus 7. Notice you get x squared minus 6x plus 9, and then 9 minus 2 gives you 7. Fantastic. Now, the next thing we want to do is find the domain and range. The great thing about this is that the domain is all real numbers every single time because it's a polynomial. And the range, we can look at this and figure out what the range is. Now remember, it opens upward if a is positive and it opens downward if a is negative. Notice that a is just 1 and that's positive, so it's going to look like the upward version. So the y value, it starts at the lowest value is at the vertex and it goes upward. So the range, the lowest value for the y is negative 2, and the upper value is going to be infinity because it keeps going. So we've just found the domain and range. Now then, the x and y intercepts. To find an x-intercept, you set the function equal to 0. In other words, you want the function value to be 0 because you want it to be on the x-axis. So what we're going to do is we're going to set the standard form here, the x minus 3 squared minus 2 equal to 0. Hey, look, this is actually pretty easy. I just need to add 2 here, giving me x minus 3 squared is equal to 2. And the square root property says that x minus 3 is equal to plus or minus the square root of 2. So I can add 3 to both sides, which means x is equal to 3 plus or minus the square root of 2. What that tells me is that we have two x-intercepts. They are the coordinate 3 minus the square root of 2, 0, and 3 plus the square root of 2, 0. Now then, every parabola has a y-intercept, and that y-intercept is always going to look like 0, a number. Now, if you're given the standard form, you have to simplify a little bit. So you plug in 0 for x, you get 0 minus 3, and you square it, you get 9. And then 9 minus 2 gives you 7. So this would be 0, 7. But if you're given the general form, it's very easy, because this is always going to be your y-intercept, because these two are going to always be 0. So that's the y-intercept. Also, we have an axis of symmetry. The axis of symmetry is always a vertical line, and the equation of a vertical line is x equals a number. And the number is always going to be the x value of the vertex. So the axis of symmetry is x equals 3. Now, I'm going to go ahead and draw that vertical axis as well as I can. So there's the axis of symmetry. I'm going to plot the vertex, 3, negative 2, right 3, down 2. Fantastic. And it's opening upward. Now, normally, and I'm going to draw this in a different color because this is the parent function here. Normally, the function, or at least the parent function, looks like this. There we go. Fantastic. So that's the parent one. What I want you to realize is that everything matters just from the vertex. If this is the vertex, and it is, if I go right 1 from the vertex, I go up 1. If I go right 2 from the vertex, I go up 4. If I go right 3 from the vertex, I go up 9. Because you're always squaring the distance from the vertex. Same thing about going to the left, you're still a distance of 1, so 1 squared is 1. Left 2 squared, 4. Left 3 squared, 9. We're going to do the exact same thing here. If I go right 1, I square 1, and that gives me 1. So I'm going to go up 1. Oops. If I go right 2, I can go up 4. If I go right 3, I can go up 9. And because there's an axis of symmetry here, if there's a point to the left, there's also a point to the right. Oh, look. If you look at your y-intercept here, 0, 7, fantastic. That's exactly what we found. And we did that just by using this information. And so this is going to be your graph. Now notice that you do have 2 x-intercepts here as well, and you could have plotted those if you wanted to by typing this into the calculator and just kind of approximating where they are. So 3 minus the square root of 2 should have probably been around 0.6 or 0.5, and then 3 plus, 1.6 or 1.5, and 3 plus the square root of 2 probably would have been around 4.5 or 4.6. So if you notice, that's about where these are. Alrighty. Well, have fun. I'll see you next time.